Hello students, today we're going to be going over an intro to expressions. We are still in Unit 6. Make sure that this notes page that you picked up on the way in is in your table of contents. This is page 109. As we jump into our notes today, we are going to be talking about the difference between an expression and an equation. So let's go ahead and define those two things together. First, we're going to focus on expressions. An expression is defined as verbal statements that can be translated to algebraic expressions. So go ahead and write translated here. Okay, so it's a verbal statement that can be translated to algebraic expressions. It is similar to deciphering a code or translating from one language to another. So an expression is a mathematical phrase that contains numbers, variables, which are letters, so that could be A, B, X, Y, those are some common ones. And it also contains operations. So multiplying, dividing, adding, and subtracting. So expressions can have any of those things in it. What it does not contain is an equal sign. That's what makes it an expression, is because you don't have an equal sign. Now, an equation is much like an expression. It has all of those three things, numbers, variables, operations, but it also contains an equal sign. So it's a mathematical statement that shows two expressions are equal, and it must contain an equal sign. That's what makes it an equation. So now farther down on your notes page here, it says classify each representation below as an expression or an equation, and then explain your thinking in the last column. So based off of what we just talked about at the top of our notes page here, we're going to go through and we're going to define whether or not we have an expression or we have an equation. So looking at this first one here, I've got 8 times the quantity of 12 minus 20. Now, when looking at what expressions have, they have numbers, variables, and operations, but they don't contain an equal sign. So in this case, this would be an expression because there is absolutely no equal sign. There are numbers and there are operations. I have multiplication going on here and subtraction. So I have those things. But I don't have an equal sign. So on the explanation, I want you to put has numbers, and I'm just going to put the hashtag sign for numbers, has numbers, operations, but no equal sign. Okay, so that's what makes it an expression. For the second one, I have 37 minus x equals 90. So over here, I have an expression, 37 minus x. That's a variable, a number, and an operation. Then I have an equal sign, and then I have another number over here. So this is saying that 37 minus x is equal to 90, which means that because I have an equal sign, this is an equation. And you would just write contains an equal sign or has an equal sign. That's what makes it an equation, okay? Number 3 is a statement. It's words, and it says 17 minus 2. So that would be written as 17 minus 2, which makes it an expression. Because there's no equal sign in 17 minus 2. It's just 17 minus 2. So you could say it's a phrase, because those are words, with numbers, but no equal sign. Next one is 19 plus 4x plus 8. Now I have numbers, I've got some operations, I've got a number with a variable, but again, no equal sign. So this would be an expression. And you could write no equal sign. Okay, next is 5 times 10 is 50. So if I was to write this out using numbers, this would be 5 times 10. And actually, I'm going to go ahead and just erase my equal sign because, or not my equal sign, my multiplication sign, and I want to use the dot because we're moving into algebra. And I want us to get comfortable using the dot instead of the X sign because now X has a different meaning. It's a variable. It's no longer your multiplication sign. So this would be 5 times 10. So 5 multiplication sign 10. Is the key word here. Is means equals. Is the word for equal sign. It is 50. So we're saying that 5 times 10 is the same as 50. So this would be an equation. And you would say phrase with numbers and equal sign. Because of the word is our equal sign. Last but not least, we have 4 times 25. Remember, no sign means to multiply. Equals 100. So this is an equation. And you could write contains an equal sign. That's what makes it an equation. So now we're going to label the parts of an expression below. Right here, the expression that they gave us is 4d minus 9. Okay, so my 4, of course, is what we would call a coefficient. Okay, that's your number that's attached to your variable. So this is a coefficient. Again, it's the number that's attached to your letter, your variable. Now, I know that this is a lot of new vocab and a lot of new words here, but just bear with me. The number that's attached to your letter is your coefficient. The letter that's in your expression is called your variable. Together, those are called a term. Okay. Your subtraction sign is, of course, your operation. That's the mathematical operation you're performing. And the number by itself is called a constant because nothing changes. It's constant. This will constantly be 9. No matter what happens to your variable over here with your letter, this is a constant. It will never change. It's always going to be 9. Okay? And then all together, your 4d minus 9 is an expression because there is no equal sign. Okay. Now, flipping to your next page, we're just going to do the top part together, and then I'm going to have you guys work on this by yourself. So it says, using cards A through B as an example, use algebra tiles to model the expressions in cards C through D. So, for A and B, let's look at this closely here. I have this expression, 3x plus 3. So, I know that this model is modeling 3x plus 3 because I have 1, 2, 3 x's. So, that would be 3x. And then I have 1, 2, 3 1 tiles. So, all together, there are 3 x's plus my 3 tiles. For B, I have 2 plus x plus 1. Okay, so I have 2 tiles, 2 1 tiles. Okay, so together that's the number 2, plus an x, which is modeled right here, plus another x, which is modeled right here, plus 1. Okay, so those are in order for you. 2 plus an x plus an x plus 1. So now for C, I'm going to go ahead and model the expression that it gives me based off of my first 2 cards. So if I have 2x as my first term, then I can draw x and another x. Together that's 2x. And then I'm going to take away 3. So that means all of my little boxes need to be a -1. -1, -1. All together making that -3, taking away 3. For card D, I have x minus 3 plus an x. So I'm going to go ahead and draw an x. And then I'm going to draw 3 -1 squares, making that a -3, plus another x, positive x. And those would be my models for my expression. Okay. Now we're going to talk about which expressions above are equivalent and how we can justify our thinking here. So if I have over here for C and D, if I have 2x minus 3, which means I have 2 x's, this is 1 plus another 1, so 2 altogether, minus 3. This model for C is the same as my model for D. It's in a different order, but I still have 1 x here, another x over here, plus my 3 -1 squares, so my -3. So I know that C and D are equal. C and D are equal. They both have 2x minus 3 in their model. They have 2 positive x bars, and they each have 3 -1 squares. Okay. Now looking at question B, it says Catherine is asked to write an expression that is equivalent to card A. What expression could Catherine write? So if we're looking for something that's equivalent to card A, we have 3x plus 3. Now we could break that apart, right? Maybe we can change up the order. What if we had, say, 2x plus another x plus 1 plus 2. So what I'm doing is just kind of breaking apart my terms here. I'm breaking apart my 3x and my positive 3. If I was to draw that model, that would be 1, 2, 3 x's, right? Because I had my 2 x's here. 1 plus 1 is my 2x plus another x. Okay. And then I would have a positive 1 box, and then I would have another positive 1 box and another one. So this model here, which represents this expression, is the exact same as this one here. I just broke up my 3x and my 3 and wrote a different expression that was equivalent to card A. Now, don't let that confuse you. I know that this is a lot of new material and you're working with models, but we're going to continue with this understanding together. So go ahead and make sure that this paper makes it in your math binder. We're going to finish this worksheet together. And just go ahead and close your laptop so that I know that you're done watching this video.